Okay, welcome and everyone. Welcome everyone. Officially, we're starting. And as I was saying, today we're going to be learning about sockets and sockets programming, a little bit of basic networking. We're not going to go into much theory because that's not where we do lots of theory. You probably learn about the theory and I'll give you references as well. But we learn about these in like computer networks and communication networks. These courses, and we have content for these. But today we want to focus more on the like hands-on programming aspect. How can we use system calls or operating system features that allow us to do networking on our own? So that's kind of the purpose of this session. And before we get into the coding, there's one thing I wanted to ask you guys about. How many people here have their own learning plan or learning curriculum? Raise your hand if you have one. So like you have your own personal curriculum that you follow or you're trying to learn through, and like you're sticking to and following up like on a yearly basis, let's say. So anyone has that? Anyone? Okay, we have Kareem. Okay, so Kareem has a learning plan. Okay. So do you just like we can actually have a discussion on this. So do you just like whatever topic that comes to mind, you go ahead and learn it, or is it hello Muhammad Adnan, or do you have like something structured that you're following? Okay, so I think most people do not have one. So okay, so it's spontaneous. Okay, and obviously, so you have like the university, they give you a curriculum. Okay, so let's actually talk about this first. I think that's something that we can discuss. Just a random topic that I see interesting. Okay, cool. That's a good start. And we can talk about whether that's good or not. So let me share. So that's our first 5 minutes of discussing curriculums and having a personal plan. Can I share? Yes. Chrome. It's going. Okay. Okay, so let's we're talking and thinking together, and if anyone wants to open their mic, you can go ahead. Okay, so if you like randomly chase topics or like pick whatever like comes to mind, you'll find yourself, okay, you're learning about random bits all over the place, but you're not getting really competent at one thing. Okay, you're building some breadth, which is important. You're learning about different things, but still, it's not very focused. It's not gonna get you at a level that makes you valuable for someone in probably an employer in that field. Okay, and that's why or where a plan or a curriculum comes into place. So it's important to have a plan. That's one. So we need a plan. But how do we make one? How do we make a plan? Let's so two components. We have you, okay, or maybe that's not you. That's okay. That's you here, okay. And then you have a target, okay. So you need two things. You need to know yourself, okay, know your abilities, know your current strengths, know your current weaknesses, what you have, the resources available to you, that kind of thing. And you need to have a goal, okay, and we can talk about these two things. But let's say how many again, how many of you have a specific learning goal? Let's see this. Okay, we have a couple. Okay, Cool. Okay, so we have more goals than plans, it seems. Uh, okay, okay. So, for example, my goal, which is a little bit open-ended again, is to become a really, really, really good cybersecurity engineer. So that's me. Everyone has their own goal. So, and my goal is, I mean, you can have a goal like I want to just be able to maintain a good GBA, or my goal is to be able to get a good salary, regardless of maybe of the topic. So maybe like if you find something else other than tech that will give you a good salary, you can follow that. uh, or like if you're focused on GBA, so you're focused on like proper like exam taking habits or like studying habits or that kind of thing, regardless of that, of whether that's going to like make you a good engineer or not. So you see like how the goal or the goal you pick to yourself or the goal you state can affect the way you move or the way you pursue that goal. So now that we have a goal and we have ourselves, okay, let's talk about ourselves. It's important to perform a self-assessment. Okay, so like get a piece of paper or like your favorite note-taking app, and like try to do one, like what am I good at? So maybe like even like create a table. So we can create a table. So strengths, weaknesses, that's weaknesses, that's strengths, and I'm very good at drawing with a mouse. And like try to list them. How many things you're good at? How many things you're not really good at or you wish to be better at? And then now you have this. They call it like a skill inventory. What you have, and that will help you, for example, like identify areas for improvement or areas where you're already good at, so you need to capitalize on or invest more in, and it will improve your like your all over the like the plan making process for you. And then now that you have these two components, I hope you get the idea because I know I'm all over the place, but I hope you're getting the idea. So you have your self-assessment, you have your goal, and now you can start drawing a line of how you can get to that goal. Without these two components, without a goal, you'll be a little bit distracted or very, very distracted, unfocused. And I believe like many of us went through that phase, like, watching random YouTube tutorials, reading random stuff, maybe trying a project here or there, but not really like pursuing that one thing. So that's why it's important to have a goal. And again, we talked about self-assessment. Having these two components will make it easy to have a plan. So once we have a plan, or like how do we get that line first of all? Like how can we draw that line? So you either start from your goal and backtrack. So see like, okay, I want to become a cybersecurity engineer. Okay, read, do your reconnaissance, map the industry, ask people, talk to people. Of course, you have like Reddit, you have Quora, you have all of these sites where people are going to like spell their experiences and their personal like personal job seeking experience or how or their own life story, and you can get like actual gold wisdom nuggets from these. YouTube, for example, a day in the life of the kind of videos, get that kind of idea, lists, and like watch and read so many things. The more you watch and the more you read about your goal, the more you formulate a kind of generic or perception of that goal, and the more you remove biases, because maybe if you listen to just one person, that guy obviously he has biases, but the more you read and the more you watch, you'll start seeing points where they all agree on, some overlapping, and that point is what you should take and consider in your goal. um, yeah. And then now the plan itself, after you do your reconnaissance here, so you're doing reconnaissance, you're um, like expanding on all areas around your goal, getting a better perception of it, again on yourself. How do you gain reconnaissance on yourself or what you're capable of? So that's another topic. So it's mainly through exposure. So the things we're doing right now gives you exposure. Competitions. So if you go and compete and put yourself against highly capable people who are able to, maybe they're way better than you at the field, that gives you exposure. It tells you more about your capabilities, how you compare to competition or colleagues, and it gives you an idea of what you're lacking, what you're missing, what your strengths are, what your weaknesses are. And then you take these and you build your blend. So it's going to be like, I need to learn this, 1, 2, maybe this 2.2, maybe it has like some dependencies. So like you can write them down, then 3, and then you list your plan. And I have one. So I have one for me, for example, for cybersecurity. And you slowly, or like you gradually have that plan in front of you. Now, even if you don't stick to the plan, so this importance of that, even if you don't stick to the plan, it's going to be useful. It's going to be a baseline or something that you always like compare anything that you do against. So am I deviating from the plan? Am I on plan? Is my plan or the thing I laid out like 1 year before, is it actually a correct plan or something that's useful? And again, it's something that's continuously like evolving as you talk to people, as you read more, you make changes to your plan. But it's important and crucial that you have one. If you don't have one, again, distraction, getting nowhere, and it's really a mess. You need a plan. Just like any project. Can you imagine like a large scale project at an enterprise worth tens and hundreds of millions of dollars without a plan? No, that's not going to happen. That's like if you tell me I have that project of that size and I don't have a plan, that's kind of like you're joking. You're not taking this seriously. So treat yourself as a project. You're more valuable than tens and millions, hundreds of millions of dollars. I hope you have the potential. So, and if you're serious about that, then you should have a plan for yourself and your learning. It's something that you can extrapolate from the like project management side of things. You're a project. Okay. So is that clear so far? Can we start with the sockets programming? Oh, do we have questions to start with? Guys, Ahmed, Ali, tell me if there's questions getting sent to me. Oh, there's a bot here. Okay. Okay. CTFs. Okay. Okay. Okay, I think we can start. So just to close this, once we're done, you can get your pen and paper and like try to formulate, do your self-assessment, build your skill inventory. What do I have? And then try to think of a goal. Probably you have a goal, but it's not written, but you should write it, have it down. When you write it, you're gonna see flows or things that are missing, and it's overall more structured. And then build your plan. And then, yeah, and then follow it. So stick to the plan. That's one important thing. Okay, so let's get to the sockets programming. So let me have Obsidian. Or actually like a bit of networking theory before the sockets programming. Okay. Obsidian. Okay. Okay. So in this session, we're not going to talk about two things, because networking is too broad. We cannot actually cover networking in one session or two sessions, or it takes actually decades to say networking. We're going to learn networking. So no, we're going to learn about something specific, which is TCP over IP, and we're going to talk about that. And more specifically, we're going to spend some time on TCP, because it's very, very critical. Understanding TCP is very critical for so many things. for cybersecurity, understanding TCP means you can understand exploits, you can understand different different attacks, you can exploit different services. It makes you can't really do cybersecurity without understanding TCP. It's something critical. For the rest of us, network engineers, programmers, back end, front end, whatever, understanding networking is gonna is gonna like make life easy for you. Okay, uh, many web developers, for example, when they come to deployment or they come to uh, how they interact with websites, maybe if they're more on the back end side, they or like when they're working with APIs, because of the lack of fundamental networking theory or and practice, they struggle a lot, and they waste time in things that they shouldn't if they had networking like really at the fundamentals covered. So let's have a quick introduction to TCP over IP from my notes, and it's gonna be quick, and I'm gonna like push you over to resources and stuff to read if you wanna like expand on the theory, because we're not gonna like cover theory in depth, just like a quick primer. Okay, so TCP over IP is a collective name that's given to the technologies that compromise or comprise the internet. Okay, so it's not just two technologies, TCP and IP. It's the whole stack. We call it the IB suite. Okay, and it's made of so many protocols. By convention, people agreed that they're going to divide these or the protocols in this stack into categories. Now, if you've done networking, of course you know this, like computer networks, but they agreed to divide them into several categories, just for the sake of like it's a convention, nothing that's like you're not going to open a network packet and like find application presentation or these things inside. It's just a way that we use to understand or separate things better. It's for us humans. So there's two leading models: the OSI model, the Open Systems Interconnection model, I believe, and we have the TCP/IP model, and they divide like these categorized protocols into like application, transport, internet, network interface for TCP/IP, and for OSI they divide it into these seven layers. They call them layers. So, and there's like documents dating back to the conception of the internet, and they're saying like it is, guys, it's better that we divide these protocols into these categories, and each category or each layer should have its own like use case, and restrict each protocol or each category of protocols to one use case. And like in many networking exams or stuff, they're gonna ask you like which layer does this protocol belong to, and there will be like debates and like whether it's like session or transport or whether it's like both, and but it's nothing really to like focus or like fret about. Just know that they exist, and like we have different layers for protocols. We do have a question. So those protocols, we're gonna discuss protocols, but they decided that each protocol should be given or assigned to a certain layer. Okay, and each layer should be dedicated to a certain functionality. So, for example, when we have like physical layer, it's dedicated to the physical world, so how things or signals get processed in the physical world. Network layer, the protocols here are like they're related to how things get routed, or how things, primarily the IP protocol, or how things traverse the networks. Transport, mainly how the data that gets sent like is like make sure that it's like the integrity of that data, that it reaches out full without corruption, or if there is like lost data, that it gets resent, that kind of thing. But these are the categories, just categories. But again, nothing to fret about, because as engineers in our work, it's just more practical. We're not like doing multiple choice questions or stuff like that. We just want to do things like code stuff without needing that kind of theory. Okay, so there's two primary protocols, TCP and UDP. TCP is the one we're gonna spend most of the time on, the transmission control protocol, and UDP we can see how that works again with netcat or something, but we're not gonna spend much time on that. The main difference, TCP is connection oriented. That means it requires an initial agreement or initial connection before we get to send data. UDP is just you send data and that's it. Like there's no kind of and again, this is theoretical, but we're gonna see the how that plays out in real life. So TCP is like a formal interview. UDP is just shouting at someone and not caring whether he hears you or not. We can discuss that, but actually, let's actually see this in real life. That's the way TCP protocol looks like. Okay, so let's actually do the because this part is going to make more sense when we do it in practice. So let's actually let's do this, and I have my let's share my touch screen. Okay, so the way you can follow up on this session is you can do it with MSys, or for me, I'm gonna do it inside the virtual machine, whatever is more suitable for you. Okay, and I'll try to give instructions that are cross-platform. If you're working on WSL, that's fine. For Mac, I think I can give you commands for Mac as well. But yeah, if you're on MSys, we want to download something. So I'm going to do backman ss for demonstration. So I'm going to do backman ss, and I'm going to do openbst netcat. Okay, I believe it's called openbst.
Adham.
Yes.
So if you're using Windows, for those who are using Windows, we need to use the software you're talking about, right? What was the name of it again?
MSys. So that's the one
Exactly.
we installed last time.
Exactly, yeah, that's the one. For Mac, can we just use the terminal directly?
You can, but the thing is, we want to install this. We want to install netcat. Do you have netcat by default on Mac? So try to type nc or netcat default command.
One
So
second.
if you're on Windows, you wanna download this inside MSys, which we installed last time. So I'm gonna do Control-Shift-C, openbst or backman. We're gonna search for that package. Okay. Oops.
So no, we don't have it by default on Mac.
You don't have it. Okay, so do you have Homebrew installed?
Yes.
Okay, so you can do brew install and netcat. So we have netcat. Okay, let's actually
Thank you,
search
sir.
for netcat. Okay, and then we want to install this. So that's because there's two variants of netcat, one written by GNU and one written by openbst, and we want to use this version. There's slight differences, but it's for the most part they're similar. Okay, so once you find it, you can copy the name and then backman-s and then openbst netcat. Proceed with installation, yes, and then it can install here. For the time being, I'm going to open my virtual machine. I'm gonna work from there because I want to show you other stuff as well. But you can follow up from Windows or Linux or Mac, doesn't matter. So let's open Kali. So a virtual machine is just a sandbox or a simulated computer inside your computer that you can work in and do things independently from your primary operating system. And I have a Kali Linux machine here that I'm going to be running inside of my Windows host.
And then we have a question by Saeed that says, any reason for using the virtual machine over the computer directly?
Yes, I have a demo, and that demo requires some software that are only available on my virtual machine. But the demo it's not gonna affect the what we're gonna do. We're gonna build the same thing, and it's gonna be like you're gonna have the exact same thing like mine. And we're gonna see now. I'm gonna show you. So, oops. Okay. So until that boots up, let's see if we have netcat. Okay. So now that we installed this, we're gonna let's actually start with the. Can you see, is the font all right?
And I'm sorry for interrupting again, but I'm
Go
reading
ahead.
the comments so you stay focused on your screen instead of switching.
Okay.
Some people are asking to show the commands again.
Okay. So we have backman -ss. That's for search. That's if we're searching for a package, and then we identified we're looking for netcat, and we found two variants: new netcat and OpenBSD netcat. We're gonna use the OpenBSD variant. So select that, right click or Control Insert. We have different kind of weird shortcuts here, and then we're gonna do backman dash capital S, and then paste that, and we should have it. Now I installed that already, so it should be fine. I don't want to install it. Okay, I'll leave that here for a while. Now, the first thing I want to do is talk about netcat. The self description is TCP over IP, so that's a stack we were talking about. Swiss Army knife, very very simple. Netcat is one of the utilities. Now we're bringing back the first sessions on why we learned command line in the first place, because learning the command line gives us the flexibility, the power to interact with the system at a lower level. Now we're starting to use that power, that thing we learned, for interacting with the networking capabilities of our operating system. Okay, and one of the tools that help us do that is netcat for networking. So let's start with netcat --help. Okay, and we have lots of options. Okay, I wanted to see the man page. I think we don't have that here. Okay, we don't. Let's actually do that I want to show you the manual page for netcat. So netcat is a UDP TCP tool that allows us to start servers and clients in using both protocols. Okay, and we're going to use it for demonstration. So let me actually clear the screen here, and let's bring this here. Let's get another one. So okay here. So how do we start a very basic connection, TCP connection? How do we start talking with TCP? Okay, so let's say we have, or that's something that we have already. We have google.com. Okay, can someone tell me like what port is like Google running on, like as a website? It's running HTTP. Okay, so what port is it running on? What port number? I need an answer. Should I check myself? Okay, 80. Okay, so it's running. Okay, we know that it's running HTTP, but HTTP as a protocol, or most of our protocols, are running on these two core protocols, TCP and UDP. Okay, so if the HTTP protocol is running on TCP, can we just communicate to it or talk to it TCP? So let's see that out. Okay, what happens if we say connect with netcat, which we have? Do we have the NC? Yeah, we do have. Okay, so we can either type netcat or we can type NC. Okay, they're same thing. So I'm gonna do google.com. That's very simple usage. Okay, and then which is stating the host or the computer that has the service we're looking for. And then I'm going to type in 80. Okay, and then enter. What's happening? Okay, I think I know what's up. Let's do -vn. Okay, so when I added -v, okay, that's for like extra verbosity, so we can debug or troubleshoot why this is not working. And apparently, I think it is because of the like the DNS. It's unable to find what google.com is. Okay, so let's try to find, ideally, I think we should do this. Okay. Okay, here we go. Here we go. Sorry, my bad. When I added the -n, that stops DNS resolution. Okay. So like it stops this name from being converted to an IP. And we know that names are for us humans, IPs are done for the like when you try to specify a host, you specify it as an IP. And this is the IP of Google here, one of their servers. Okay, so now we have a connection open to Google. Why are we not receiving anything? Okay, we have a TCP connection. It says here TCP, HTTP, or HTTP over TCP. So why are we not receiving anything? Because even though we have a TCP connection, which is essential for accessing that website, we haven't started talking to it in its language yet, HTTP. Okay, so let's see if we type get, okay, slash, okay, and then we press enter once, and here we go. We're getting all of the source code or the for the page, for the Google front page. Okay. Now, of course, this is not meant to be like accessed here. It's meant to be accessed in a browser. So it has like stuff like this is CSS. It has some information about the background color, stuff like that, which our terminal can't really show to you. It's meant to be accessed by a browser, but you get the idea that if we can talk to a service, or if a service is running over TCP, we can talk to it. Okay, we can communicate with it, and let's see. Okay, so that part is our HTTP request sent over TCP, which is usually it's not something that we type in, but the browser sends in, and we can actually, let's actually give an example of this. So I want to show you live what is happening. So Wireshark. So we're going to use Wireshark. I mean, you don't have to install it, but it's what we use to see packets as they travel on the network, and it's helpful to get an understanding of what's going on, visualize the your network or the packets that get sent. So right now there's nothing being sent on this network. So let me open a browser. Okay, and let's like try to, let's see if there's anything. No, nothing yet. Okay, there's some stuff getting sent on here. I want to show you the HTTP traffic, or that idea of HTTP being sent over the TCP protocol. So if I do google.com here, okay, that's sent. Now, if this is something that my machine just did, I should be able to or something that I requested and I got a response back, I should be able to go to Wireshark and see this happening in real time. Okay. So let's try to, we want to filter this. So let's do HTTP. Okay, this is only HTTP. And then I want to do like source. I want to show you request. And I want to have something like, how do we filter for the site? Can we do like Google here? No, we cannot. Okay, but here's, for example, let's actually search that up. So Wireshark, find HTTP by website. Okay. So I can get HTTP.request. Or we can actually do TCP. Actually, I'm not sure how can we do this, but I want to filter for only the Google request to show you that. I'm still finding it manually. Okay, let's actually do this by let's go back. Okay, I got stuck. Okay, let's keep that one for later. Anyways, I'll figure it out. But for now, now that we were able to talk to Google as a service, let's see if we can have our own service running. Okay, so let's try to have our own port running. Okay, so I'm gonna do netcat. Okay, and then I'm gonna do dash, and then I'm gonna do VNLP. Okay, so V for being verbose, so we can have more output from our netcat script. Net for not resolving names, so just like work with IPs. I don't want to work with names or DNS. L for listening. Now we want to listen. We want to create a service that's listening, a server essentially that we can talk to, just like Google here in this case on the left. And P for specifying the port. Okay, and I'm going to specify a port of say 4500. Okay, any arbitrary number. Here we go. And what do we get? We get an alert from Windows Defender Firewall. It's telling me that do you want this program to be able to listen on your computer, on your network? And I'm gonna allow it in this case. Okay, it's nothing to worry about unless you're doing something sketchy. Now let's actually clear this, and now this service actually can get talked to by anyone in my home network, in my LAN, because it's now listening on all interfaces, and we just allowed it through the firewall. But now let's see if we can detect this service running, okay, on my computer. So if I type in netstat, okay, that's another command, and I say A is going to list all of the services that are listening on my computer, and we have a bunch. Let's actually make this smaller. Let's see if this 4500 is in here. It should be listening. Okay, let's make this even smaller. Okay, here we go. So if we look here, we have TCP under Proto. We have TCP, and we have this address. It's listening. Okay, so we know that this service is listening here, and we can talk to it. Okay, so I'm going to do netcat again here, and this time it's a client. So now we have a client server that's listening, and we have a client on the left that's going to talk to that server. And that's important, like the idea of a server, a client requests something from the server, a server replies back. That kind of thing is important to like have a grasp on. So I'm gonna have netcat -vn. Now we don't want to pass in L or P because we're not going to listen, but instead I'm going to specify localhost, okay? Because I want to refer to this machine, and localhost is a special name to refer to your current machine, or we can use the IP, which is equivalent 127.0.0.1, and I'm going to specify the port. So I'm going to specify 4500. Boom. Here we go. So we have a received a connection here on the server side, and it says I received this connection also from localhost. So it's same machine talking to the same machine, nothing interesting. And the socket or the TCP port that I received was this port. Where does this one come from? Okay, like we were listening on 4500, but why did we receive this? So it turns out that in TCP, when you listen, you specify a port that you're gonna sit at and listen at. Okay, but when you're connecting to someone, you don't really specify like where you connecting from. You just, the operating system is automatically going to create some high numbered port, like for 49,000 here, and it's going to use that to connect to your to the like destination port. Okay, now that we have this connection set up, we can actually send messages. So I can send anything. So I can say hello, and it gets sent here, and this guy, like, he says world, and it goes back to the client. So now that we have established this connection, even though like this server was the one listening and that one was the one connecting to it, now that we established that connection, we can send messages bidirectionally. It doesn't matter. So for demonstration, okay,
Allow me
yes,
to stop to allow me to pause you here for a minute so
go
other
ahead.
students can follow up with you, please, with the
Sure.
steps, just to make sure everyone is not behind.
Okay, sure. And by the way, we haven't done like sockets programming yet. We're just showing sockets programming is what is going to be working under the hood here inside netcat, and we're going to do that manually in our on our own using Python. But let's actually, like, what we're doing now is we're trying to understand or like see how these things work in the first place, so we have an idea of the project or the code that we're going to write. Okay, is like, do you have any questions on this part? Like, because when I'm explaining, or if it's something that I have done before, I might like forget, like if there is a certain like issue or thing that people commonly ask about. So like, let me know, like if I skipped something.
Yeah, please. Some students are asking about the flags that you're using after NC, VNLP. Can you please
Okay.
re-explain that?
Okay. So if we go to the, I want to go to the cat. Okay. Because we don't have a manual here, but we have dash to specify flags, V for verbose. That gives us the, it's actually, we don't have anything to lose. We can do this, and like if we do just NLP and we do 4500, okay, it's not going to print anything. It's not going to tell you that I started listening or that I received the connection or anything. Okay, or actually that's because I did this, but anyways, dash NLP. So it's not going to tell you anything. If I connect to it, it didn't even tell me that someone connected. And if I type, I think I should receive it. Yeah, but you don't get the extra messages. So we keep it just so, because it's helpful, dash V. The N is, it makes more sense when you add it to, let's do here localhost, I think. Yeah. So it makes more sense when you're connecting. So as a client, when we have dash N, N disables DNS resolution. So it disables converting names, DNS, the domain name system, or service, domain. Anyways, N prevents converting names to IPs. So if you give it a name, it's gonna tell you, I don't know where that is. So if we have dash N on, then we'll have to do the IP format for the connection. Okay. But obviously, it's better if we don't have that, so we can use names, and we can do just localhost because names are better. That's actually, yep. Here we go. Connection refused. Okay, because we have nothing listening here. We killed that. If we have that on, and we connect again, connections Oh, connection refused. Connection received. Okay. So hello. And here we have the address.
Okay, guys, I think we can't hear Adham. I thought it's only me for a second. Bear with us for a minute, and inshallah he'll join again. I'll let him know on WhatsApp now. Waiting. Oh, okay, thank you.
Okay, can you see? Okay, so did you see this part? Let me actually control C. Okay, so we are here, and I'm going to start a TCP tunnel. Okay, you don't need to worry about this part, but what we're doing is I'm forwarding, or like I'm connecting. Hello. Okay. So can you send something to this IP? Let me actually, can we split this screen? Let me do this here. So if I right click vertically, and we can be listening here to see your messages. Okay. Okay, so you want to be sending something to this address, okay, using netcat. So you send your name maybe, and it's going to be sent here to this address and then forwarded to me through the tunnel to this port 5000. Okay. So that's the address and that's the port, and that's how we specify both in a URL. So you have the what we call the scheme for the protocol we're using. We can actually go here, URL components. So you have the scheme, that's the protocol we're using, and we have the address. Oh, okay. Ooh, we have someone sending. But let me actually see if we can tell who this was. Um, okay, so one person managed to send something here, and we're still listening. I think I could send something back, can I? Hello? No, but I don't think it's gonna get to them because they're of the like forwarding this. Okay, someone sent something. Oh, yeah, he got it. Okay, and he is. I think that's Tawfiq probably. He's at at that board, and all I see is 127001. So I don't know his IP address because that got sent to me through the tunnel. So this tunnel I created, it's like it goes online and then goes into my machine, and then it gets sent to my server from my machine. So I don't know exactly the IP, except if I go here, maybe I can see inspect. Can we see? Okay. Can we see the requests we have received? Uh, I don't think I can. So I can't really find get your IP. I think there's a way. Okay, but anyways, okay, so can anyone else send something, or is it like locked for? I think it's we have two connections here. Can you guys try? Hello. So take this address. How can we like? Okay, let's maybe that's why. So if I come here, netcat dash vn, and I take this address, like let's see how it's done. And I take this address and I paste it in here, and actually we should remove the n because we want that name to be resolved. And then we add in the port 10914, mismatch of okay. Okay, it's oh, oh, I think if someone is connected, the rest don't get it, right? Okay, so like it's only the first come. Okay, so we got a connection. Okay, okay, okay. So my bad, my bad. You guys were doing it right. Uh, how can we? I think we need, because netcat only like accepts one connection and that's it. I think if we do, let's have like a Python TCP server. If we want to test this out, socket server. There was a module that we could use for. Okay, because that's gonna take some time. But anyways, okay, let's actually open a new one. Someone sent something. Someone any okay, we got a connection, and he's okay. So okay, and I hope it's not the same person. Okay, one more, last one. Okay, we got a connection. So people are spamming me probably. Okay, hello. Okay, so you get the idea. Okay, and he closed the connection on his side, so he tore that connection. Okay, so let me close this tunnel before I get hacked, and let's start building our own TCP server in Python. Okay, so you can let's actually do this in like VS Code or something friendly. So I'm gonna open with, let's create a folder. It shouldn't take much time. So TCP demo, and when I'm gonna open that, right click, open with VS Code, Visual Studio Code. Do you have any questions on like what was happening with the with that, with the like the tunnel or the TCP thingy? I guess
Yes, Rashad, can you
How do
please
we show the connection?
so. When you Control C, so once you're connected with netcat, if you want to end that, you Control C, and that's how you end it. And automatically, once the netcat process or program is ended, it's gonna tear that connection for you.
Oh, okay, thank you.
You're welcome. Okay, so I'm gonna have two files, server.py for our TCP server, and we're gonna have client.py. Okay. So first thing, we want to import socket. Okay, which is going to be our which is the library. Actually, we want to be always looking at the documentation. It's going to be it exposes to us all the networking functionality or the low-level networking functionality in Python. So if I come here and like do Python, let's keep this actually Python sockets. Okay, low-level networking interface. Okay. The reason why we're even doing sockets programming is by exposing ourselves to that like low-level networking programming kind of thing, we get a better understanding of like what is happening behind the scenes. Because now netcat is doing this under the hood. Firefox or Chrome, when you're sending something, is doing that under the hood. There's some sockets, there's that kind of thing happening under the hood. So if we kind of get to do it on our own, that improves our understanding. So I will have this documentation open, and we can look at, let's find socket objects. Okay, we don't need that for now, but it's a good habit to like always go to the most authoritative resource, which is in this case the Python official Python documentation, and use that to while you're programming, instead of like going to secondary or third-party resources that are often not as accurate or as authoritative. So now I have a socket. Let's create a socket instance. So I'm going to do socket.socket. Okay. And I'm going to have that socket saved into a variable called s, or let's call it a sock. Okay, so that's sock. And this socket is going to take two parameters because sockets come in many shapes and forms. And they have different types. So we need to specify the type. What kind of socket we want to make? We want to make an IB or TCP over IB socket. Okay, and the way we do that is we have actually two parameters here. So the first thing is we're going to define an IP socket, so using AFINet, and then we're going to specify a TCP socket. So it's TCP over IB. It's using this socket dot AFINet. That's the short word or the code for IB, or for an IB or Internet Protocol socket. And here we're going to specify the TCP or the transport type as TCP. So and that's happening through sock stream. Okay. And that's common because across the server and the client. So let's actually copy all of this, copy, and that's going to be here as well, because in both cases, and you're going to see how similar the client and the server are, but in both cases, we're creating an TCP over IB socket. Okay. So are we all good? Okay. Now, one of
Can you
the
explain what sock stream mean?
sock stream.
Yeah, sock stream.
Okay, so we can actually consult the documentation on this. But when we're building or creating a socket to start with, we have to define the type of that socket, and we have two categories to define that socket over. First, the address family, which is here, and there's different kinds of address families. So we could define an IPv6 socket using, I believe, this one, AFINet 6. So we would define an IPv6 socket. But we don't want that. We want an IPv4 socket, and that's defined through an AFINet. And you can find that online. So the documentation for like why we use that family or that is like all online. For this one, for the sock stream, this is the transport mode. Okay, so we have here the first parameter is the address family, and then here we have the transport mode, or how what kind of method we use for transport. So we could use sock, for example. There's another option for datagram. So if we use sock dgram, that's going to be a UDP socket, which is not what we want. We're going to use sock stream, which is it's not stream, which is specifies a TCP socket. Okay. Now, before we do anything, what we need to do is go up down here and do sock dot close. Okay. So close steer the connection. So whatever we're gonna do, we want to close the connection at the very end. Now we could avoid that if we use with the Python with syntax, but let's do it imperatively and keep everything explicit here for understanding. Okay, and we can do that on the client side as well. Sock dot close. Now for the server side, what we want to do is we want to listen, right? But before we listen, we need to specify an address where we listen at. Okay, so I'm gonna do sock, okay, dot bind. I want to bind that socket to a specific address. Okay, and bind takes a tuple. A tuple is a Python object that is specified with two parentheses. Can we actually? Okay, we can make this. Okay. Okay, here, good. Okay, and the first one is going to take an IP address or a name. So I'm going to specify that I want to listen or bind before listening. I want to bind on that address, and then I want to put in a port. So I want to listen on 4555. Okay. We all good? Okay, cool. Now that we have binded, I want to start listening. So I'm gonna do this. And as you see, can we have a look? Okay. So as you see, this is very, very low level. Okay, like we're interacting with the way the operating system does stuff on a very low level. And if you actually like, if you want to move to C or C++, this is precisely how it's like. It's very similar to the way C and C++ does networking. It's almost the same methods. We can actually do that, and we can have a look at that later. But it's very low level, and that's the point. We're learning how to manipulate these sockets and networking on a low level, on an operating system level, and we're having that flexibility with Python. Now, the difference between like if we're doing this in C or and Python is now this code is cross-platform. So if we take this code, run it on Windows, it's going to work. If we take it, run it on Mac, it's still going to work. And we're going to look at why that is later. But for now, let's complete this application. So we've binded to an address. We're listening on that address. But before that, I want to go ahead.
Yeah, we have a question from Ra'af. How do we know the number of the port to choose? Is it arbitrary?
Yes, it is arbitrary. So if we have a service, for example, let's say we have an HTTP service. So it is by convention that HTTP services run on port 80. So in that case, we might want to listen on 80. But since we're just creating a random service, we're just gonna set that to 455. Okay. And we're the server. We want to listen somewhere. Now, I want to like after I'm listening, I want to see if I get any connections. So if we get a connection, so we'll call it con or con. Let's keep it okay. Naming is one of the hard things in programming. So let's call it client sock. Okay. So this is going to be equal to sock.accept. Okay. So now we've binded to an address, like we locked to that address. We're listening there, and the address we've chosen is localhost, which refers to our machine, and we chose a port 4555, and now we're listening on that address that we just binded to. And now to represent let's actually do this inside a while true. So inside the loop. So we can take as many sockets as possible. And let's do, yeah, I think that's, or we can do a try. So try to accept. But let's keep it, let's actually keep it simple for now. Okay. So, and now when we get any connection, let's actually do client sock.send, or can we, or do we, let's actually print this first. So client sock. Okay. And okay, let's just keep it one connection for now. So we're not going to take multiple connections. Okay. So let's try to run this. Okay. I'm going to do Python server.py. Okay. Let's see if it runs. Okay, I think it's running. Now let's actually check that. We don't think stuff, we check them. So, and let's do, so here in my terminal, I'm going to type in, okay, I'm going to type netstat and and I'm gonna do, I want to find if there's 455. And here we go. So there's actually a port 455 that is listening on this machine. So we know that it's open. But since we added no like print statements, which is a very bad thing, we can't tell. But now let's try and connect to this. So going back to the client, this is all in the server. Okay, if we go back to the client, let's do, it's even much simpler. So if I type in sock.connect, and I do this, and it takes in an address, and that's how an address looks like, 127.0.0.1. It's a tuple again, so there's like a bracket, parentheses, inside parentheses, and I'm going to specify the same port number that we're listening at. And we can call this connection, so like a reference to our connection, and or do we not? Let me actually check this. So let's go back to the documentation. Again, going to the most authoritative official documentation is your best friend. So if I go here, connect, let's see, let's look for connect, or we have functions here. Okay, so if I search for connect, I want to see like what this function returns. So if I go here, connect to a remote socket, okay. The format address, or the address depends on the address family, okay. So that's saying that if we, like, based on what we put in here, the address family, AF, then the address here that we connect to is going to differ. It's going to have a different format. And, okay. So let's look at, now if we want to send stuff. Okay, socket.send all. Okay. So before you send anything, the socket must be connected. Okay, cool. So now that we're connected, we're gonna go here and we're gonna do, we don't need this. We're gonna come here and do sock.send something, okay? And we're going to send, it has to be bytes, okay? Hello. So we put a B here to state that these are some bytes. So we're gonna save that, and let's see if we actually receive anything, or like if the server does anything in return. So I'm gonna have a new terminal here and do Python client, or I wanna like see it, and I see them together. Okay, so can do this. Okay, so if you click on the this side-by-side split, we can have them together. And then I can do Python client.py, and here we go. So our client code did actually work, and it did send something to the server, and that's it. It just closed down. So, like right there, we were able to instruct the operating system to create a listening socket that we were actually able to that we were actually able to confirm when we did our netstat. So when we did this, now it should not be no longer listening. And then we were able to create a client that also interacts on a low level with the operating system to create a client socket that connects back to the server. I do find CR455. Okay, so as you can see, nothing is listening anymore. They're both down. So let's do something more fancy. Let's actually, instead of go ahead.
Let's give them, please, a minute to follow up with you.
Okay, excellent.
And we're open to questions. Please ask in the chat or open the mic.
Let's actually have this here side by side so everyone can see the client code and the server code. So,
and maybe now, in the meantime, while people are typing the code, you can like quickly summarize what we have done so far, or what is the.
Okay. So far we've created two files. One is server, one is client, and we can see the similarities that in both we create a socket. Before we interact with TCP at all, we first have to create a socket. Now that socket must have the correct socket type, okay, or because there's many types of sockets that you can have. You can have like UDP sockets, you can have IPv6 sockets, and there's like plenty. You can have like even in Linux, where everything is a socket, even files, or like things, but you can open files as a socket. So you can interact with the file system using sockets. So we have to define or specify the socket type. So in this case, we chose AFINet for IB, and we chose sock stream for TCP. So we have TCP over IP. These are the two protocols we're running. Running the TCP protocol inside the IP protocol. In the server, the difference is now we have to bind to an address, like lock into that address because we're going to be listening there, and then listen, and then we have to call the accept function, which allows us to accept connections after we're listening. Okay, and this function returns an object that represents the client that connected to us. Okay, so and that's what we printed here. And I think what we should have done, which I'm going to do next, is this is actually returning. Let's actually like copy the code first, and then we can move on to the differences. And now that we've gotten an object that represents the client that connected back to us that we can deal with, we just printed that for now. And then, of course, we close to tear down the connection. And here we just connect and send the hello. That's it. And like, okay, we can copy this part.
And
Question.
guys, please note that to make sure everything is working correctly, we need to run both scripts together in the same time.
Yep, that's right. So here, clear. I'm gonna run the server first. Actually, I don't like this. Okay, let's actually connect to it. Okay, we got a keyboard. Let's actually print something like here in the server side. Let's say server listening. Let's keep that here on 127.0.0, and then let's keep these like as the port. So this is going to be port, a constant that we define here. So port is going to be 455, same thing, and then we're going to have the port here in this way. So now if we save this and we run the server again, it says server is listening on 127.0.0.1 455, and we can connect back to it, and that's it. Okay, so what we're gonna do is we want this server to talk back to the client. We want them to, at least for now, we want the server, let's make an echo server. So an echo server is whatever the client sends, the server is gonna send back to it to confirm that it received it. So 5 minutes, like research that. I want you to try and find that out. How can we get the server to connect or send data back to the client? Right now, we're just taking everything that into this object, which is not correct. And it has to be done here, okay? So it's something to be done here and maybe an extra line to implement that. So 5 minutes break for that. And I'll go get some water as well. Can you guys see my screen?
Yeah.
Okay, good. So if anyone finds it, or like the first person to find it, just let me know. And if share your code.
I have a question.
Go ahead, Rashad.
Whenever I name my folder client, it does not allow me to import socket for some reason. Why is
Yeah,
that?
I guess in Python you can't name the folder the same name as the what do you call it, the file, the Python file. I've
Ah,
read
all
this.
right.
So maybe that's the remedy. I'm not sure.
Oh, okay. Thank you. Adham, do you mind sharing your screen with the code, please?
Yes, sure.
Thank you.
Okay, so and we're gonna see in a few seconds how we can take this same code and turn it into a useful security tool, turn it into a security scanner. So we're gonna turn this into a scanner that can use of the the parentheses, right? Okay, so we can take this same code and our knowledge of TCP and how it connects and form a security scanner that can detect services running on your or on other computers. Uh, did anyone get the like sending talking back to the client?
Yeah, I managed to do it. So
Oh,
cool.
nice. Okay, so can you share the code with us? So
Yeah, sure.
tell me like over the air, how can we change this?
So you say like the received message with a client.sock. That's what I did at least. Dot receive recv and then 1024 dot decode.
But is this line correct? Line 12? I think it's not.
You need to unpack it first. So maybe
So
like
we're gonna do connection.
yeah, and the address.
Okay, so we're gonna have connection and we have address. So so we have accept returns two things. It returns an object that represents the connection that we just accepted and one that represents the address. So we can use that to say something like print, to like print information about the. So the connection object is what we use to talk back. So if we hover over this, it's going to tell you that con is of type socket. Okay, so it helps us communicate back to the client or the thing that connected us. Address is just an address that of that connection. So we can use the address object, and we use that syntax to unpack it, or like basically like take the first element of what is returned. This returns an array, so it returns an array, returns an array of a socket one, and then an address here. We take the socket into a variable called con, and we take the address into a variable called addr. And we can print the address, I believe, if we can say something like received connection from, and the inside the address we have a couple of things. So I think it is remote address. So we have remote or like address dot remote address 0, I believe. And here is going to be the port, so it's going to be address dot remote address 1. Again, this we can find this on in the documentation. I hope this is right. So if we save this and we run, we're listening. Now if we table object has no attribute, our address, I think it is
Adham, just index it directly, please. Address at index 0 and without
sure,
router. Yeah.
because okay, so we have this. One is the address, one is the port. Now if we listen again and we connect, here we go. So it says we've gotten a new connection from that port. From again, because it's the same server, we can get we get localhost and we get a random port for the client. Okay, now let's actually communicate with that. So we have connection dot. What do we do, Ahmed? Do we receive? We can receive. Okay, so we can receive whatever the client gives us. So I can say, let's listen for like take everything he offers now.
Adam, what I didn't understand is this parameter or argument we're passing, 1024.
So
Is it the
we
number?
number of bytes that we want to receive. We don't just like receive everything infinitely, or like we just receive a block of data, and we choose an like it's common to use multiples of 8, because I don't know, convention, not convention, but like deep down and like operating system level, it's better if we or in the network, I guess they recommend using multiples of 8. So 1024 or multiples of 2. I read that somewhere.
Maybe a question would be, why not just having a very, very big number, just like in case, like in general, in real life applications?
Because in real life applications, that's not just like it's not the full data that you receive, it's just a chunk. So the chunk that you're going to receive is common to be it's commonly a multiple of, or is this a multiple of 8? No, is it? Not sure. But anyways, it's common to like use that kind of number as a chunk, the size of your chunk, and then you keep repeating. So as you see, it's like in a while loop. So we keep receiving that kind of these chunks and like gathering them. So I can do. We can actually copy this until no data is found. But so we can do while true. We just keep receiving chunks to keep the connection on. Con.receive. So data. Yeah, we're gonna have some data here. And if not data, we're gonna break the loop. Otherwise, we can just print the data. I think we can encode it or decode it into, okay. and like remove the new line. Okay, so we're gonna like print everything that we just received from this client. Okay, and we can actually, like other than repeating, like printing it, we can send it back. So we can say con.send, and we can send it the same data back. Okay, let's actually try this. So I'm gonna listen. Let's make this a bit bigger. Okay, so I'm gonna listen, and I'm gonna execute this, and an established connection was reported by the software. So I know why this is happening. Okay, so in Windows, if we check, it says that the connection wasn't able to happen, or like it did not happen. Let's do this again. Connection reported, established connection. Okay, your host machine. Okay, so it has to do with this con.receive. Let's check if it is. Okay, so it's not listening. Okay, let's see what we're doing wrong. Troubleshooting. So we have here, we have the client program, and then we have this server program. So we have a good example here, actually. And here in listen, I think we specify the number of connections that we want to receive. So if we do listen, we can look at socket objects, and then we find socket.listen.
Why are you doing line 3 relative to your cursor? It's dot send.
Where is line 3? 1 second.
Line 3 under 17, I mean, يعني, under your cursor. Last two lines.
This one,
Yeah.
condescend. I wanted to like talk back to the like like echo everything that the client sends to me. I want to give it back to him. So like if I get hello, I receive it and then send it back to him. So if we have con.send, oh, I'm actually not sharing this part. Listen, okay, let's actually, oh, Tawfiq shared something. Let me share. Okay, so connection aborted, established connection. Okay. So is it because we didn't put the code? Okay, so it says that we need to do this here, but I'm not sure. I think, all right, let's try. Okay, so we're past that. Okay, so that was it, Tawfiq. Bytes like object is required, not a string when we're sending this, so we have to encode it back to. So when we're okay, so let's explain what's happening. So when we're receiving data or we're sending data, there have to be they can't be strings. Okay, they can be just a string, a Bison string. They need to be bytes. And the way we convert a string to a byte, because bytes is the format that's common, generic, that everyone can understand. Because this string could be like maybe that S is encoded using a different scheme or different, like in different bits. We have, like we talked about ASCII, we know we have Unicode, we have these kind of things. So we have to encode it first into bytes using a common encoding scheme like UTF-8 or like Latin one, which is like 8-bit ASCII, which is basically saying that every character needs to be given 8 bits. Okay, so we have to encode that before sending it to the on the line, and we have to decode it whenever we receive it. So we can actually like do this as well here, and we don't need this here. Okay, so if we send this, hopefully, okay, we're listening. If we connect to it, okay, what's up here? I'm not sure why is this failing. Maybe, okay, let's actually do this. So you're getting a real-time troubleshooting experience. Okay, here we go. So it was the while loop, but okay, I want to fix it, but for now, okay, I will fix it. But for now, let's see what's happening. So now, if we clear this, and I have a server on, and then I run the client, I receive a hello from the client back. Okay, and I'm not getting anything on the client because I'm not trying to receive on the client. So if I do on the client, like the client is just sending and just closing the connection without worrying or like trying to even get what the other side is saying. So we can do something like this: 1024 decode Latin 1, and we can have the data here, and then we can print server said, and we can add the data. We can add the data here. So clear, and then run the server, and then if we run the client, we get this hello from the server, and then server said hello back. Can we see this? And again, before we receive anything, we have to decode it, or before like we interpret it, we have to decode it into ASCII, or Latin 1. Latin-1 is the code name for ASCII in Python. Like I think if you use ASCII, that's like 7-bit ASCII. We have to use Latin 1. And before we send anything, we encode it back into bytes. Are we clear? Let me see the comments. Is everyone following? I know it's a little bit, it might be a little bit okay, Hamad, confusing. Okay, all clear. Okay, so let's actually see that, and I think you get the experience. It's very low level, and there's like you have to know what every like piece of every method, every function is doing exactly before. Let's do this. It can get like very low level, and we're not even like, we're doing a very basic example. We're not sending anything or like doing anything fancy, but that's the point. Sockets is very low level, and it helps you understand networking. If that's of course an example, we're not understanding much, but it helps you if you get to that, or like if you spend time doing sockets programming, it helps you understand networking better. Now, can we let's see, I want to show you one last thing. So when we have a connection, so let's like send the connection here, right? Okay, can you see this? No connection could be made because the target machine actively refused it. Okay, let's do the following. I want to show you Wireshark. So let's again. So if we do all entire screen. Okay, so I'm gonna open Wireshark. Oops, I think I made a big fatal mistake. I shouldn't have opened it as non-admin. Okay, so Wireshark, run as administrator. Yes, okay. So I want to show you what that looks like. Because now, okay, so let's look at my loopback interface, okay, and I want to look for TCP.port that's equal to 4555, okay. Right now we have nothing. I'm filtering for all connections to this port. So let's do this, or not two, like any connections that involve this port, whether to or from. Can you see this? So what happened is I tried to connect. First of all, do you see my whole screen, right? You see Wireshark?
Yeah.
Okay. So I tried to connect. Okay, when I tried to connect, that's what happened. There's some random port here. That's if we, I don't know if it's big enough. Okay, here, this port 51797. Which port does this or like who does this port belong to? It's a client. Okay, the client that's talking. And it's trying to connect to port 4555. So it sent that packet. That's the first one, and it contains this flag, which we can like. We need to look at the if we get back to here, this. Okay, can you see this SYN? That bit, that specific bit in the TCP packet, that's the whole TCP packet, or the shape of the data that gets sent. I know this looks scary, but it's not. It's very simple once like we look more at it. But SYN, that's the synchronization packet, or it says basically I want to talk. So this port said to that port I want to talk, and then that other port 4555 actively refused it. It said it sent that RST, and this is the intended behavior by TCP. Whenever you're not listening, you send back RST, and this is done by the Windows operating system for us. In our case, it got a request to a service or a port that's not listening. There's nothing running because I'm not running. If we go back to this, I'm not running a server here. It's done. So it sent RST. Thankfully, Python tries to repeat that request or the which function here. So the connect function tries, like when it gets refused, it tries again, and then every time it got refused. So it says no connection could be made because the target machine actively refused it. And we can see these refusals with RST, and we have okay, it's a TCP retransmission, so it's not Python. It's the automatically done by TCP, and that's what happened. It got refused. Now, what happens when? Let's clear this, or we don't have to. Let's run the server, okay, and let's connect. Okay, so we have now we have this part, which was part of the old connection attempt, and then we have this part. Interesting. So we have SYN, okay, this part, synchronize. I want to talk to you. Okay, and that's automatically done by TCP for us. Like, okay, we're doing low level, but we don't have to get that low and like modify these. Like send a SYN or send a SYN ACK or this kind of. It's done by the operating system for us. In some cases, in security, you would like to modify these on a more or on an even lower level, and we have like things like row sockets where you modify the single bits in every request and that kind of thing. But that's like more advanced. Here, when we sent a SYN, we got a reset back, and that's TCP behavior. If we look at the TCP standard, we'll find that. If we even go TCP or RFC 793 TCP, I believe. Yep. That's the standard that was created in 1981 by the DARPA Internet Program. And if we go back, it describes the behavior of TCP. If we go back to, if we type in SYN, and I want to search for I don't know why. I think in Chrome you cannot. Okay, so synac. Okay, so it talks about the different flags in TCP. It talks about, okay, here we go. So you have all of this diagram. It says how things should look like, or how the protocol should behave. And it defines every interaction. So if you're trying to establish a connection, if you're trying to connect, if you receive a SYN and you're closed, what do you do? Actually, I'm not sure. Okay, if you're closed, we see, I'm trying to, but anyways, you'll find it somewhere here. If you receive a SYN while you're closed, you send back an RST telling them that no, reset, I'm not available. But on the other hand, if you receive a SYN and you're open, which is in our case, the server was open, was listening. So this port here, 51849, sent to 455, SYN, I want to talk. 455 replied back, it said,